Okay, so here we go with our matrices solutions, and in part A we're asked to calculate m times n, the product of these two matrices. So the number that goes in the first row and the first column of our new matrix over here is going to be formed by multiplying the numbers in the first row and the first column of our two matrices in the multiplication. So I've got to do 5 times 3, which is 15. And then I've got to do 3 times 4, which is 12, and add those two results together. 15 plus 12 is 27, and that's what goes over here. Now in the next part of the calculation, I'm doing the number that goes in the first row, second column. So I'm going to multiply the numbers in the first row of the first matrix with the numbers in the second column of the second matrix. So that's 5 times minus 6, which makes minus 30. And then I've got 3 times 2 is 6, and I'm adding together minus 30 and 6 to get minus 24. Carrying on in the same way for the second row first column, I've got the numbers in the second row times the numbers in the first column. 1 times 3 is 3, minus 2 times 4 is minus 8. 3 and minus 8 together make minus 5. And then finally in the second row second column, I'm multiplying the second row over here by the second column over here and adding those together. So 1 times minus 6, negative 6, minus 2 times 2, negative 4, negative 6 and negative 4 make negative 10, and so that's our product. So that's m times n. Now this thing over here means m inverse, and there's a formula for the inverse matrix which you should learn. If my matrix M is equal to A, B, C, D, it'll always be a 2 by 2 matrix, then the inverse of that matrix is 1 over AD minus BC, and then I jumble up the numbers in that matrix. A and D swap places, and B and C get minus signs. So all I have to do is think of this like a formula and just substitute into it. So the inverse matrix for M over here is going to be formed by first of all making the fraction 1 over AD, which is 5 times minus 2 minus 10. Subtract BC, 3 times 1 is 3. And then I've got to do that jumbling up of the numbers. A and D swap, so the 5 and minus 2 swap places, and the other two elements get minus signs. Of course you'd want to write this as 1 over minus 13, just to tidy it up, but that's the inverse matrix M. So in the next question, I'm asked to draw the reflection of shape S in the line y equals x. For this question I just brought out the bit that was to do with matrices, so obviously there will be more jobs to do with Q and R in the full question. Now I'm going to explain this in two ways, and it's very important to understand both explanations. If your course did not involve matrices, then we'd be quite happy just to stick with a geometric interpretation of what reflection is. That means we can imagine what the line y equals x looks like, and we would now look at the journey of each of these points to that line, and we'd continue that journey to the side. So for instance, this point over here, I would have to cross 2 diagonals to get to that line. So I have to go 2 diagonals out on the other side to find out where that point ends up. Let's call this point A, and let's call its reflection A dash. Now I could do the same thing for another point. Let's take this point over here and call it B. This one goes 1, 2 and a half diagonals to get to the line. So a half, 1, 2, it ends up over here, and that's going to be called B dash. Now A and B are connected, so A dash and B dash are connected. Now we could do the same thing with this point over here, C, or you might feel at this stage that you've got enough information by itself to continue to draw the shape. Just to show it one more time, I'll do the same thing with C. That is 1, 2, 3 and a half diagonals. So there's my half, 1, 2, 3, C ends up reflecting to there, and so my new shape looks like this. Now if we look at those two shapes, we should be able to see that there is a symmetry in that diagonal line. Now in order to understand what the next part of the question is going on about, the matrix that represents this transformation, we have to think about what's happening to the coordinates. Now whenever you are reflecting in the line y equals x, you are essentially swapping the x and y coordinates of any given point. Let's take for instance the point B. The point B, its x coordinate is -3 and its y coordinate is 2. When I reflect in the line y equals x, I'm simply taking the x and the y coordinates and swapping them around to find the new point. So I'm expecting B' to swap around the 2 and the -3. And let's take a look and see if that's true. The x coordinate of B' is 2, and the y coordinate is -3. And if you look at every point we've worked with, you'll see the same thing has happened. So for instance, C has an x coordinate of -5, and it has a y coordinate of 2. I'm expecting C' to swap these two numbers around. We can see very clearly it has an x coordinate of 2 and a y coordinate of -5. If we are reflecting on the line y equals x, all we really have to do is reverse the x and y coordinates. So, we're talking about this because we want to be able to write down the matrix that represents this transformation. So, here's the story. Whatever happens to the x and y coordinates is going to happen in the matrix. So our matrix, whatever it is, needs to take an x coordinate. Let's take the simplest one we can, which is 1, 0. And it needs to flip it around so it becomes a y coordinate 0, 1. Now whatever it is that goes in here is going to be these two numbers. Okay? Now our matrix also needs to take a y coordinate 0, 1 and it needs to turn it to an x coordinate 1, 0. And that's going to be what happens in the second column. So whatever happens to x's goes in the first column, and whatever happens to y's goes in the second column. So our matrix, we'll call it M, is going to be 0, 1 because it flips x values to y values, and then it's going to be 1, 0 because it flips y values and turns them into x values. Now, because this question says write down the matrix, there is a sense that perhaps you should learn what this is, and there'll be a couple of key transformation matrices they just expect you to know, but for the purposes of this worksheet I'm going to show you how to work them all out. So I shall do more questions in the next video.